Without further ado, I'd like to introduce our first speaker, who is Sandra Carrico. She is the VP of Engineering and Chief Data Scientist at WattzOn. Sandra?
Yeah, it looks. Thanks. Hi, just checking the mic. Move it up a bit. Here we go. Oh, you got it. Thanks.
Great. Well, thank you so much for joining us here today.
Thanks for having me.
Great. So why don't you tell us a little bit about WattzOn?
So WattzOn began as a company aiming to help consumers use less energy. We had engagement platforms, we had messaging, a variety of techniques were applied to this problem. And one of the things that we ended up doing was extracting data from permissioned consumer accounts, energy accounts. And so we built a system to do that.
Got it. And we're at an AI conference. Tell us a little bit more about how AI machine learning is kind of embedded within that.
So at first we just built this system straight away as a scraping system. And that worked pretty well. But I started to notice as we were scaling it that we were going to have some problems chasing the changes that would be occurring in the forms in which the utility data was presented. And so we had to find a better way to do it. We were going to end up scaling economically linearly with the number of utilities. Now, WattzOn covers basically all 50 states. And we can extract data for about 90+% of all America. So one big contract, and we have an awful lot of change possibly underway. And so I asked myself, is there a better way to extract that data and make it less expensive for the company to maintain? And that was the genesis of the Mr. Bill product.
Got it. And before we go on to, and I would love to ask you more about the Mr. Bill product, I also want to get a sense of the people who are in the room. So across sort of startup, tech company, investors, so raise your hand if you're from the startup world. Okay, and then bigger tech company and investors. And what am I missing? What's the group others? Okay, cool. So that kind of help us gauge the conversation a little bit.
Oh, and one more question. How many people are like software engineers and implementers?
Okay.
And how many people in kind of marketing and more business side? 50-50.
Yeah.
Okay, that's going to make it fun.
Yeah. So you guys had a big announcement this week.
Yeah.
Tell us about that.
So Mr. Bill was finally benchmarked on a sufficiently large data set that we could get an error bar. And in the benchmarking, we discovered that Mr. Bill was extracting data with an F1 score, and for the marketing people, put it in percents, it was 98%. That meant we were at 99% precision and 98% recall. That's fairly good. In fact, people who do this kind of data extraction at scale in the commercial space, they typically use humans to do this extraction. They have 2 people who do data entry in conjunction with supporting software. And even with 2 people, they're at about they're at like 90%. It's very hard actually to pin people down to what their numbers are, but they're nowhere near 98%. So we're superhuman, not against just 1, but 2. 2 humans today.
It's very interesting, really, really exciting.
Yeah.
So next, because we have so many implementers and practitioners in the room, I'm sure they're more interested in hearing about how you led your team through that transformation as well. So how did that all get started? So we talked about the fact that we had to scale the system. And as we started to scale it, the first thing I did was I was using AI throughout the company for point products. And I had talked to my professors, and they had told me, well, if you're going to use AI, what you need to do is look for things that are in classes that we understand, or find clusters, or predictions, or maybe outliers, which really was a description of how to use AI, and much less a method for finding new, novel applications to AI, which is eventually what Mr. Bill became.
So that was how it began. And then what happened over time was that I found myself in this very difficult spot. And I started, out of sheer necessity, I started saying, what can I do to make scraping better? And I discovered that AI was an abstraction technique. It really wasn't all these other techniques, although it certainly is. And when I did that, I had a huge improvement. There was a huge change that took place. So the economics of the business was able to change by making it an abstraction technique. And in addition to the economics changing, engineering got very simple. And we stopped gating on how many engineers we had and how quickly they could code. And instead, we started gating on how quickly we could get new ground truth in and how much ground truth and how much data we could get in. It turns out, fortunately for us, Mr. Bill doesn't require a lot of ground truth. About 20 examples is all it needs. But by switching that way, we moved the bottleneck away from the developers and into a different area where it was easier to source people.
So you mentioned that once you started looking at the problem from a different perspective, a lot of things changed. What were the maybe metrics, or what were you looking at? What were you tracking to?
So one thing that changed that was really interesting was so as you know, we started in energy, and one thing I started to discover was that market adjacencies changed too. Because although we went from residential to commercial, which is a natural thing to do.
Absolutely.
I was sitting talking to a friend of mine who is a former VP at Apple and now doing research in genomics. And I mentioned what I could do, and I said, I can scrape data and I can extract it at really high accuracies. And he said, oh my God, Apple just bought a company and they desperately need data extracted from their healthcare records. I'm like, well, a form's a form. I don't care. I can extract it. And so sitting at dinner, he's sitting there texting this guy going, do you need data? I think, I know her. If she says it rocks, it rocks. And he's like, oh my God, do bears poo in the woods? Yes. So the adjacencies became different. And let me explain why that is. And why the business people wouldn't necessarily find it as easily as maybe the engineers might. The reason is that the problem was so deep in the assumptions that business has about what can be done and what can't be done because they've been beaten into submission by their engineers. No, it'll never work. That the engineers are actually saying, oh, it will work now. And these limitations, these coding limitations, are spanning industries. So in the case of scraping spans industries. So anybody who's dependent upon scraping can now benefit from this kind of system. Now, of course, it solves scraping for this case of structured data or semi-structured data where you have many examples that look the same to humans. But that occurs a lot. I mean, there's a lot of cases where finance has it because sometimes people want to extract 10K forms faster than perhaps Fred puts it, the Fred system puts it online. Or the healthcare industry where there's isolated things. And Mr. Bill works for both PDFs and images because that's what I had to do. And it just goes to a single source. And because we're a tiny company, I couldn't do anything by hand. It all had to be automated. So all the tuning's automated, all of the model generation is automated, all the recall. This is all and it runs, and we didn't have any people to chase after it, so I had to build an entire platform that would scale elastically because I didn't have the resources to just put up machines and let them run. So everything had to be elastic and expand and contract.
So you brought up a point earlier that I want to bring us back to, which is a little bit of this natural tension between engineering and perhaps the folks on the business side. And I think this tension is probably particularly interesting in this room today because we do have both audiences. So as a company who is trying to solve hard problems, and as a leader in a company like that, how do you reconcile kind of the two different sides?
Right. So, I mean, it is a problem.
And make sure they're collaborating together, right?
Yeah. I mean, this is hard, right? Because both sides are committed to their roadmap, and change is hard for people. And so changing people's direction can be really disruptive. In fact, it was even disruptive within engineering.
Yeah.
I thought about this problem and I thought, oh man, I know this great answer. It's all the buzzwords. Engineering's going to love this. And I just dumped this in the middle of an engineering meeting thinking people would think I was great.
How did you do that?
I said, oh, I have this idea. We could fix some stuff inside the Link product and we could make it really automated and use AI. And this is kind of how it would work. And the entire engineering organization threw tomatoes at me. I thought I was going to be killed. I'd never seen such a negative response. And I just hadn't anticipated that, they were committed to a certain method and a certain way of thinking. And that's so disruptive for people to, have a new method put in front of them. And so, what we did to make that change happen was I said, all right, it's good. I understand that it looks scary and dangerous. I'll prototype it.
Yeah.
And so I ran the prototype, and I did that actually between Thanksgiving and New Year's a year and a half ago. And once I did the prototype, then people went, oh yeah, this could possibly work. But then we have to move it over into the business side and convince business, they want to sell this and perhaps pivot to healthcare. Again, another big, we don't know about healthcare. We need to learn about that. Another big thing. So these things take time.
So that's rare too. Having that come from the engineering side. Usually, that the genesis is more from the business side of the house, no?
Right. I think the reason we were able to do that in my case is I did spend a fair amount of time in marketing. I did inbound and outbound marketing for a company that had an international presence. And so I was marketing domestically and internationally.
So you had a good understanding of how companies interact with customers.
Exactly, because I did product management, product direction. And the other thing that helped is I've started my own companies. I've done business. There's these models, the economic models that investors are looking for. And so by having had a more rounded approach than just being an engineer, that helped me to bridge the gap. But I don't think I'm that unique in engineering. I might be that unique in engineering having also this AI experience.
Yeah.
But I think there's in most engineering organizations, certainly at an executive level, there are people who have been in other roles. And so the strict engineer can explain that to the engineering person who can make that bridge. Yeah. And then they can move that over if it doesn't reside all in a single person, which in this instance it all did. But I think that it can work across multiple people as a team.
And that kind of brings me to the next question, which is, how do you get that engineering perspective communicated well across the company?
Well, you mean the engineering business perspective?
Yes, absolutely.
I think that it really just takes a lot of interaction with people. Anybody who's done sales knows it takes 5 touch points before you can really close a deal. And so just be ready as an engineer, expect it. You're going to have to say the same thing 4 or 5 times in order for people to fully grok what you're talking about. It's just the way things are. It's the way humans work. We shouldn't be, upset about that. We know how computers work. We need to understand how humans work. And so with patience and, slow transition, these things can be made to work.
Got it. So I think one thing that this is a super interesting case of engineering's kind of taking on the problem solving. Is there a simple formula you think that can be applied to identifying these opportunities across different companies, different verticals, et cetera?
Yeah. So it certainly took me a lot more work to do this than I had hoped it would take. Because I had taken this feedback from my professors on how to do it. And if I were doing this again now, there were definitely some things I learned that I think everybody in this room could benefit from for novel applications to AI. One of them is look for places in your code where things are changing a lot. You just use version control. Look at it. Where are things lighting up? Those places may be better served with AI, because what I found was AI serves as a new form of abstraction, and that abstraction allows us to better and more cleanly implement solutions. Look for heuristics. People who are for example, if you're doing DevOps, there's a lot of heuristics there. Maybe that would be better served with an AI engine rather than somebody twiddling a lot of dials all the time. Let's see, I made a list before I came to make sure I would get all of these different kinds of things. Areas with high maintenance cost, that was another area, and that was certainly something I benefited from. Areas that require prediction, that stays the same.
Yep.
And any place where staffing levels increase. And one of the reasons these particular types of questions really will help the practitioner is because it helps the business. When you ask these questions, you're going to the heart of the operations and the profitability of the business. And so it's a much easier sell to say, look, if we adopt this system, we change our economics. This money is going right to the bottom line.
Yeah.
And that makes it a lot easier, I think, for people.
Yeah. Well, thank you so much. I just got the 5-minute warning, so we're going to start taking some questions from the audience.
Okay. Yeah. Go ahead.
Sure, go ahead.
Could you please repeat what Mr. Bill does?
So Mr. Bill is a system that can take as input either PDFs or images, and it uses forms. It looks at forms where you might have many of them. In our initial case, we had utility bills, but healthcare records is another case. The list goes on. So any place where you have a volume of the same kinds of forms that you wish to extract data from, Mr. Bill can return that. So you would say, give me the amount due in the case of a utility bill. And you would just say amount due, and you would point out where it was, and then you would train 20 examples. We picked 20 mostly because people want superhuman results. And so we're pretty sure at 20 you're going to get it. But in fact, when I was starting, I just used 1 or 2 because I didn't have anyone marking my data, and I would just run it through, and it would mark for me. But that's how it works. Does that answer it, or is? Yeah. Okay. Yes, and back.
Yeah, have you tried? Does that apply to scraping websites where data can change anytime on the front end, the back end, the tags, the structure, everything changes all the time?
Yes. In fact, Mr. Bill was originally envisioned as a 2-part project. And at the time that I began it, I had both a solution for websites and a solution for documents. And we had to just pick one. And for reasons I cannot explain to you, I picked documents. I have no idea why. In retrospect, it was probably a wise choice because I think there are a few solutions for websites as well already in the market, whereas there were no solutions in the market really for documents in this case. So.
Other questions from the room? Well, thank you so much, Sandra.
Thanks for having me.
Thank you for joining us. Oh, that's great. Thank you. All right, so I'd like to welcome up our next speaker, David Cox. He's a director of the MIT-IBM WattzOn AI Lab. And David is the inaugural IBM director of the MIT-IBM Lab, first of its kind industry academic collaboration between IBM and MIT.
Great, thank you.
Thank you for joining us, David. All right, so to start, maybe tell us about the MIT-IBM WattzOn AI Lab. What do you guys do?
Great, so just a show of hands, who's heard of WattzOn before? Okay, not to be mistaken with WattzOn, the company you just saw. Could I also get a show of hands? Anyone from our legal department? Okay, so WattzOn is the name of IBM's cloud AI and analytics business. It's also the name of the founder of the company. And so in IBM Research, it's the TJ Watson IBM Research Center. We have a new lab in Cambridge, which is really the first of its kind, I would say, in the world in terms of a model for interaction between industry and academia. So
And
what?
How long has the lab been around?
So the lab is very fresh. So it was announced in September.
Okay.
And the basic deal is that IBM's dropping $250 million on a 10-year commitment.
Chunk of change.
Chunk of change.
Yeah.
Yeah, a small chunk of change.
Yeah.
To have a collaborative effort with MIT. So the way we work is we have jointly conceived and jointly executed projects with MIT faculty. So our people and MIT people get together and work on projects together. And this is in contrast to other sort of models that have been sort of are out there in the world with industry academic collaboration. So there's a model where a company comes and they throw money over the wall and researchers do research and the company hopes to get value out of it. There's another model where Uber came to Carnegie Mellon University and seeded 40 projects and then hired 40 faculty. The entire department sort of picked up and moved and now works for Uber. So that's great for Uber, but it's a little bit less great for Carnegie Mellon. And
For the world.
and for the world, perhaps. But so what we wanted to do is have a model of sort of a stable, happy collaboration where we don't sort of, kill the golden goose, but we can work together. Yeah.
Who owns the IP that comes out of this collaboration?
We both do.
Okay, so you both profit from it.
Yeah, exactly. So, and that right there is actually the magic of the entire thing. Lawyers figured, we're going to have breakthroughs and discoveries in AI, and that's going to pale in comparison to what the lawyers did at
They
the
just
very
got
beginning.
started in September. So.
Yeah. So we just got started in September. I'm the first director of the institute, and really what we're focused on is trying to get those fundamental advances in AI that are needed to get AI into every part of enterprise. Not just the parts that we can address today, but really everything that we do.
Is enterprise the focus? What are some of the problems that you guys are working on right now?
Right. So IBM's focus is largely on enterprise.
Yep.
We're especially interested in healthcare. Healthcare is a place that it's difficult for AI to make impact. As the speaker before mentioned, a lot of health records are these sort of awful, messy, doctors typing, unstructured text into fields. Being able to really understand that and leverage that is hard. We have products that do that within the WattzOn Health business unit, but we'd really like to drive that much farther. The other thing is that mistakes aren't okay. So move fast and break things is great, but not when people's health is on the line, not when people's privacy is on the line. We also have a significant focus on security. This is a huge problem that's coming for the world, that AI introduces new security problems, both in the form of AI-driven attacks on existing systems, on networks, on computers, but also AI now becomes a new attack surface. So we have AI systems. AI can be hacked. So there are a variety of different kinds of ways that you can trick AI systems. There are a variety of ways you can poison AI systems to make them do things that they're not supposed to do. There are a variety of ways you can steal models, steal the training data that was used to train the models. So these are all areas where enormous opportunity enabled by machine learning and deep learning and AI, but also a whole host of new challenges that we're trying to get ahead of.
You mentioned earlier that you talked about two different industries, and I'm curious too. Where are you seeing industries where AI or machine learning is being implemented more, where there is more traction, and what makes it difficult or easier to do that in a certain industry?
Right. So I would say at this point in history, in 2018, the thing that AI is good at, machine learning, I mean, we're getting more comfortable calling it AI, but academics, I was a professor for 10 years, so I'm much more comfortable saying machine learning, but I'm getting used to the word AI. The reason we like the word machine learning is that most of the systems we have today are sort of fixed function sort of mappings. We have a kind of data, and ideally we have lots of it, and lots of labeled examples, and then we can build a system that puts out some kind of output that's useful for us. And if your problem fits in that mold, the current technologies are extremely valuable. The problem is that a lot of problems don't fit into that mold.
Yeah.
So if you have not a lot of data, actually people talk about big data all the time, and then sometimes you find out how much data they really have, and you're like, it's not really big data. That's small data.
Just data.
And we should kind of lean into that, right? Because a lot of the interesting problems we have are actually small data problems. A lot of the things we do in enterprise, we just have like a pile of spreadsheets, or we have a database that's a little bit, sort of crufty and it's not quite curated right. We have, industry data, transaction data, all these kinds of things, and they're just not necessarily in a mode that you can just, put them into a deep net and say go. You really have to have a system that understands something about the data it's looking at, that can intuit, that can reason about the data, that has knowledge about your industry, that can leverage knowledge from outside sources. So all of those kinds of problems, healthcare is a great example of it because it's one large case where we have lots of that kind of data where, a doctor can look at a doctor's notes and understand them because that person's a doctor and they know the actual domain knowledge. But it's not a healthcare specific problem at all, right? It's every industry has domain knowledge that if you're an analyst or you're a data scientist in a company, you bring that knowledge to work with you and you can look at the data and you can understand what it means, understand what this heading probably means based on your industry. But to have systems that can be sort of more generally intelligent, that can go in and you can just say, here's what I want, go and do it. We're far from that today. Not so far that we can't see the solution, not so far that it's not tantalizingly close, not so far that we don't think we can invest and get there. But that sort of unlocking that full potential is really what the lab is about.
Got it. You also mentioned kind of security, and I know we got into biases of AI systems earlier when we were doing a little prep talk. Can you go into that a little bit as well? Sure.
So I think the sort of theme I would sort of put forward is, AI comes with challenges and it comes with opportunities, and some of those challenges are actually because of the new opportunities, right? So the more and more we give over decision-making power to machines, the more and more we have new problems that we didn't have before. So tremendous opportunity. We can now automate all kinds of things we couldn't automate before. But now we're also in a situation where we might have a system, for instance, imagine a system that's trying to make decisions about whether somebody should get a loan. This is actually a pretty interesting market. There's lots of people who can't get loans because they don't have credit history, for a variety of reasons. So you'd like to be able to make an assessment about whether they're a good bet for a loan. Or you could imagine, even in sort of a sort of more sci-fi version, making legal decisions about recidivism or something like that. In those cases, our current technologies, it's very difficult to guard against bias. So if there is a correlation in the data that's coming in, our current tools more or less pick up those correlations and then drop them back out into the world, right? So if people of certain races are more likely to be denied a loan, that's in the data, and your system is going to pick that up. It's going to inherit all of our own human biases. It's not really the machine learning algorithm's fault. It's just more like you give it humanity and it gives you back humanity. And what we want is actually not humanity most of the time. We want something a little bit higher, so we can kind of hold ourselves to a higher standard. So building technologies that aren't biased, where we can specify, hey, we don't want this kind of bias to be present, or we want tools that can tell us when that bias is there.
How do you monitor against that bias?
Yeah, that's a great question. So, and that's one place where human interaction is sort of still critically important, because the kinds of groups we would want, the kinds of biases we want to protect against ultimately come down to our own, we have to define those. And we have to constantly be looking for these biases too. So, one of the things that we're especially interested in the lab, in the projects we're doing now, is this idea of building tools for debugging neural networks and debugging AI systems. So one thing that's sort of interesting, like in the 90s, people had said that software was going to eat the world, and to a first approximation, that's kind of happened. And now I think it would be fair to say that AI is going to eat software. And the previous speaker sort of alluded to this. But the interesting thing about now with AI versus then in the 90s with software is we don't actually have debuggers. So we don't have actually a debug tool chain, which is, I can see the devs in the audience sort of like shaking their head. Like it's that's the path of madness to be trying to create robust systems without a robust tool chain for understanding and debugging your systems. So one of the things that we're investing heavily in, and bias is part of this.
Yes.
But also just errors, vulnerability to adversarial attacks. Having an actual tool chain where we can get AI systems to explain themselves, explain why they make the decisions they do, and then also interrogate when they make mistakes. Why did they make those mistakes? So we can go back in and fix those problems. So this is sort of a dual-edged sword, where on one hand we want to empower people with the right tools to make AI do what we need it to do, to empower them with sort of surveillance systems to be able to say when something's going wrong, to detect bias and things like that. And then also, ultimately, if we're going to be confident in the decisions, if we're entrusting life and death decisions or life and death of your business decisions to AI, the system better damn well explain itself at some level, right? We shouldn't have black box decisions that are sort of critically important, that are driving the company or driving people's life and welfare. We should be having systems that can actually rationalize and explain why they made the decisions they made, so that we aren't in a mode where people lose trust in AI. And that's a big piece, I think, as well, in terms of if we're really going to have AI get everywhere in business, everywhere in enterprise, everywhere in all the parts of our lives, we really need to have trust.
And how far away do you think we are from that today?
Yeah, we're making progress. So I think there's a common meme sort of going around that AI is completely black box, completely unexplainable. This is terrible. That's probably a little bit overstated.
Just a little bit?
Just a little bit. Just a little bit overstated. There are issues, right? Like we don't often know why systems fail. Who here has seen adversarial attacks? Adversarial example generation. So for those of you who haven't, basically, you imagine a system that classifies images. So you put in an image of a cat, it says cat. You put in an image of a dog, it says dog. It turns out you can carefully craft the image so it's got just a tiny imperceptible amount of noise on top, a little perturbation of the image, and you can get the system to classify that as whatever you like. And there are even physical space versions. So a group of students at MIT in course 6 made a 3D printed object that from every angle will fool a deep learning system into believing it's something else. So they made a little turtle and all the state-of-the-art deep learning systems.
Images when you're young that looks like two different things.
It's like that, but only for the AI, not for us. So for us, it looks like a turtle. For the AI, it says rifle. There also are examples where people have created stickers that you can put on street signs to make autonomous vehicles misclassify them as other kinds of street signs.
It's terrifying.
It's terrifying, right?
It's terrifying.
Yeah. So so if you imagine the world projected forward a little bit, where we have not only an increase in sophistication and reliance on AI, but we also have an increase in sophistication of bad guys who want to exploit our increased reliance on AI. We're going to need to be able to get in there and understand why these systems are making the decisions they're making, and we want to have the tools that when we get in there, we can figure out what's going wrong and try and fix it. So adversarial examples are just one example of a sort of a new problem that these things will give rise to. There's also what's called a poisoning attack. So if you can introduce new data into the training set, can you trick the system into doing something potentially very specific, under other circumstances? So a good an inadvertent example of a poisoning attack was Microsoft had a chat bot that they released on Twitter. I don't know who gave clearance for this to happen, but they had a learning Twitter chat bot on Twitter with Twitter people tweeting at it. And it learned what you would expect to learn from Twitter. So they basically took, it was called Tay.ai, and it went from being, kind of a funny teen chatbot to basically, radical, supremacist, whatever, emitting terrible things. So that's an example where if you give people access to the training data, and there's lots of ways you can subtly get into the training data, people can start to make these things change. So coming up with the technologies that we really understand why these vulnerabilities exist, that we can guard against them, that we can see when they're happening, that's going to be really important. And that's why that's kind of one of the foundational pillars of what we're doing in the lab.
A lot of what we talked about so far today is more on the application enterprise side. I want to bring the conversation kind of back to the unique position the lab is in, which is collaboration between academia and industry. So what are some challenges and opportunities in this kind of collaboration?
Right. So I presume everyone here understands the value that MIT brings to the table and pretty much anything it does. Hands raised. Yeah. MIT good? Yeah. Okay. So I did my PhD at MIT in 2007 in course 9. So it's my alma mater too. MIT has this incredible strength, incredible brand. People from around the world come to MIT to build what comes next, right? And they come on a sort of a 5-year clock, right? So a PhD takes 5 to 7 years to do. So there's this constantly turning over workforce. So there's incredibly dynamic, incredibly rich. You have the best faculty in the world. And then, but on the other hand, we're in an interesting crossroads for AI in academia, where and so I was an academic working in AI for many years, and it was becoming increasingly clear that it was difficult to compete with industry after a point, because industry just had way more GPUs and compute power than we could ever hope to have. So Google would publish a paper, and they're like, hey, here's our thing, we did it, and it took 200 GPUs for 3 days to train the thing. And I'm sitting here in an academic lab, and like, we just don't have those resources. So increasingly, and then the other issue is that a large fraction of academia has now been privatized, so they've hired away a lot of the people. So we're at this interesting place where industry is absorbing academia in many ways, and being in a position to outcompete it on just sheer resources. So what our lab tries to do then, though, is to say, like, well, we recognize that there's this incredibly valuable thing. We have all the smart people from around the world sort of coming together with a common purpose at MIT to make things happen. We have this incredibly dynamic workforce. Can we bring them the resources of industry? The other thing to be said is, there's value in people who aren't in their 20s, right? Like, people accumulate. I'm not just going to walk into the forest and to go die now that I turned 40. There's an experience that comes with being a seasoned researcher for a long period of time. And academia, unfortunately, doesn't really have very many positions for those kinds of people, but industry does. So we have this interesting mix where we can have senior engineers who are seasoned, who have been doing this for a long time, who have the resources in sheer compute and data and all of these areas, together with this incredibly rich academic environment at MIT, which you all have benefited from, and we can work together, right? Of course, there are challenges, and one of them, the first one that was raised, was like, well, my gosh, what do you do with the IP? And to the credit of some lawyers, like those issues have been largely sorted out. There's still a cultural difference, right? Like companies. I was going to say that.
Yeah. Seems like a really big cultural difference.
Sure. Yeah. So companies want to drive value. We want to patent things when we can. In academia, oftentimes, and particularly in the field of deep learning and AI. The ethos is very much to put everything on archive, in the public, in the open domain, everything, all the code on GitHub as soon as humanly possible, because everyone's trying to not be scooped, right? So there's a little bit of a difference in attitude. And I think that's where our collaboration model is actually really, really important. Because if we were to just give money to university and say, hey, go do research and tell us about it when it's done, we wouldn't be in a position to really be there working shoulder to shoulder, making commits to the same Git repo, working in the same Slack channels. That kind of shoulder to shoulder collaboration is really important for a company to be able to extract value. Not that we're trying to treat it like an extractive resource, but the faculty we work with, by and large, I think are stoked that what they're doing can actually have a slipstream that takes it out into product. I mean, there will be startups. We're okay with startups, and that's very much part of the MIT ethos. I've had a bunch of startups. It's a good thing for the world. But a lot of these ideas don't make sense in startups. So to the extent we can take these new technologies that are being invented and give them a route to productization through IBM, an enormous multi-100,000 person company can bring to bear some of these technologies that would be almost impossible to do otherwise. That's actually a plus in many cases for the faculty. And because we're working so closely, we can make sure that the IP things are sort of handled sort of along the way and in a sort of non-onerous.
You mentioned extract value. What is value here?
So value, so there's lots of different kinds of value. So clearly we're interested in new technologies, intellectual property. We want to be able to take new approaches that have been developed and get them into the product as soon as possible so that everyone can benefit from these. There's also, we want to increase the profile of IBM research, right? There's an enormous talent war that's going on, where it's, if you have a PhD in machine learning and in AI, you're in high demand. And if you don't know it, if you're in the audience, you're in high demand. You presumably know it. So having us sort of be able to win that war is another big part of what we're trying to do.
All right, so we have time for one audience question. Anyone?
Question about, this is more about the survival of the fittest philosophy. How is it that you are mitigating the AI becoming fitter and surviving over human beings? Because right now, the principles governing AI, very few of them governed by human empathy, human compassion, and it's very important. If you have a chatbot out on the internet like Microsoft, why did this happen in the first place? Because we're talking about a superior species, and we're letting that happen.
Yeah.
And it happened. Human beings are not the fittest; they are intellectually smarter. That is why they are a dominant species. And there are a lot more species physically stronger than us, but they're not able to dominate because we're smarter. If we're letting a software get smarter than us, we're releasing a mutant species which is much smarter than humans.
Yeah, yeah. So will what we're working on end humanity? Is that what you're asking to verify? Okay,
Yeah.
perfect. So
Dystopian question.
yeah. No. That's entirely.
An
I think that's an
interesting
incredibly legitimate concern. So and our perspective. So one of the things we actually have is we have people working on AI morality actually. So we want to build systems that can simulate or have a moral sense that matches with our moral sense. And again, this is part of explainability as well. So like if it makes decisions that have a moral component, you'd like them to make decisions that are consistent with how we make decisions. There's also a concern, one of the pillars of the lab that when we founded it was shared prosperity. So we actually even fund economists as part of our work to think about how we do labor transition, where we move from the economy in its current state to where it needs to go. Our perspective is very much about augmentation. We don't want to replace people. We want to make people have superpowers, right? We want to be able to take work that would just be unreachable. Like you can't do this operation on a spreadsheet with this one spreadsheet. You want to do it on all of them. You want to take all the data, pull it from sources that maybe even can't get easy access to, and just have the system go out and do it. Those kinds of superpowers, that augmentation, is what we're looking for, and I think this sort of we're very East Coast, and that's why I think we're a good match for MIT. Our mode isn't move fast and break things. Our mode is let's be the responsible grown-ups in the room, and let's make sure this.
Okay, remember where you are.
Yeah.
We're not responsible.
Yeah. There's plenty of grown-ups here too. I mean, it's just like we have this kind of slow and steady sort of ethos to what we do, and I think that's an important part of that is sort of is to make sure that we do this, that it's good for people, and that we're not making sort of reckless moves that endanger our privacy or that take away our humanity or take away our jobs or cause economic harm.
Well, thank you so much,
Great.
David, for
Thank
joining
you.
us. All right, I'd like to welcome up our last speaker, Vinay Seth Mohta. He is a managing director at Manifold, an AI product development studio. Hi, Vinay.
Hi.
All right, thank you for joining us today.
Absolutely.
All right, so tell us about Manifold. You guys are a AI product development studio. What does that mean?
Yeah, so we basically help large non-tech companies accelerate their development around AI-related initiatives. So if you have a roadmap around AI, we want to come in and try and help companies accelerate that.
And do they always have a roadmap? Do you guys kind of go in and help them define that also?
Yeah, that's a great question. I mean, oftentimes we get people who come in and say, I need to do AI. My board told me I need to report back on what we're doing around AI.
Big tech company people.
Yes. It's a little bit of what Zia alluded to earlier, which is, these are sort of keywords you should watch out for when you hear questions like that. It's just, what can we do with AI? Because that's really an answer. It's a tool, right? It's a technology. It's not inherently going to tell you what business value there is. So I think there's definitely a whole strategy part, which is what is your business strategy or go-to-market strategy. And there's several of us who have experience having done multiple startups before and worked at larger organizations. But in general, we try to partner with other organizations like a McKinsey or a BCG or an IDEO to sort of bring into the sort of company's level strategy conversation, and then we really want to be in the product and technology strategy, and then actually hands-on building production systems. That's what we're all engineers, and we love doing that. So.
Is there an example of a project that maybe you can tell the room about?
Sure. Yeah. A couple of different examples where we started little bit more towards the strategy end, and then got to actually where we could build a product. So, we worked with a large industrials company last year. They had a bunch of oil field equipment, and they had a thought. The CEO had a thought that they could do something more intelligent, with the sensor data coming off the devices. It's a fairly common, opportunity you might hear about in pretty much any industrial manufacturing setting. And so, the question was, what can we do with this data? Can we predict, when faults are going to happen? Are there other things we can do on this data? And, anytime in these kinds of conversations, I think it's generally applicable. And particularly, I think about this when we have non-tech related conversations, that people start with this background image or sense in their mind of almost the generalized AI idea. AI is something magical. And again, as Zia said, it's statistics, it's an optimization tool. And so really, if there's no signal in your data, it doesn't matter. There's nothing we can pull out of it for you. There's nothing magical we can do. And so oftentimes it's actually dialing back a little bit to ask, well, let's figure out if there's any signal in your data, right? And so in this case, anyways, we did figure out if there is signal, and then we figured out what are the particular use cases in which we could predict something about the devices, and then actually put a product out in the field that's now being tested. So that's one example. Another one where much more aligned with a CTO saying, look, I know exactly how I'm going to get business value, but I don't have people who are experts in machine learning in my organization. Can you guys come in and help us? So the two areas, just as a backing up to what we do as a studio, the two areas we focus on are data engineering, which is really building your complex data pipelines to get your data available for algorithms, and then actually thinking about what machine learning approaches you could apply. So in that case, they knew exactly, they had the business problem articulated as a large organization as well. And they said, we need to build an entity resolution system to identify people that are the same across several different data sources. So that was a much more of, we have really our role is technology strategy, which is what might be a right approach to take, what do we want to build, and then actually helping build it with a certain set of skills. So there's a couple different examples along the spectrum of how much strategy are you doing versus how much hands-on keyboard expertise are you bringing.
What are you seeing as more common, and what is the trend moving towards?
Yeah, so I think in general, given the amount of increasing awareness, so our focus is non-tech companies, so we're not talking to the Googles and Apples, we talk to energy companies and education and healthcare. And I think with the broader awareness, there's definitely more and more interest of, it feels like there's a new tool here, and I think fortunately people are coming around to really what the question they want to be asking is, are there new things, new ways to get business value that we hadn't considered before? And there's an increasing interest in that. So I think in that sense, we're moving to where there is an internal effort to let's figure out a go-to-market strategy, a business strategy. And again, there will be organizations that can help figure that out, and they're building up expertise around how to use some of these technologies for go-to-market. Which then makes our job a little bit easier, where we're actually helping folks who are chief digital officers, chief technology officers, SVP of product, SVP of technology, in these organizations, and actually helping them identify, okay, you could either wait 6 months to hire your first machine learning engineer, or you could think about partnering. Now, it might make a lot of sense to do both, depending on what you're trying to do strategically with your organization. Yeah. We definitely see sort of more folks coming into those roles, which is an external signal almost that, okay, the company realizes there's something different than the CIO function, which is another interesting dynamic in large non-tech organizations, where does the CIO fit in all of this? So we could have a whole separate conversation about that.
Yeah, that's actually where I want to move to next a little bit. So you work with a whole host and spectrum of different kind of companies at different levels of recognizing the importance of AI machine learning in their industries. Who is successful? Like, what kinds of companies are typically successful? Yep. And for the ones that are not, what's what's hindering them from that?
Sure, yeah. It's a really big question, and so I'm going to try to just take a couple of facets of it. I think in terms of who has done it and been successful, one, I find, this will sound a little simplistic, but maybe another way to ask this also is who are the companies that are sort of furthest ahead in some of these, adopting some of these areas in their core business. And it's really where there's a very direct connection with money. It's sort of the simplest way to say it. So financial services, you'll also find in e-commerce, online commerce more broadly, there's a very direct connection with conversion and money, and the ROI story is straightforward, the application of technology and the benefits are straightforward, and so those are the places that tend to be furthest ahead. I think within some of the other sectors that we might consider quote unquote backwards or further behind in technology adoption, I think there are actually pockets of significant innovation. So I think in major companies in every sector, there's some key area where there's hard stuff happening, where computation is being applied. So in life sciences companies, computational genomics has been happening for 10 or 15 years, right? In oil and gas companies, you've been using fairly cutting edge, large amounts of data to do geological exploration, seismological exploration. So it's not like all of oil and gas has never seen technology, but there is really, I think, and this goes back to sort of finding some of the business cases that can then motivate what we're doing. Motivate the adoption of technology is thinking about some of those non-core cases where really you're not trying to go in and tell the doctor how to diagnose the next patient. You're actually using machine learning to figure out how can we reduce the turnover rate of nurses. That's a huge cost for health systems, right? And there's a tremendous opportunity there. So there's a lot of, I would say, non-core areas where there's a lot of opportunity to bring in AI in organizations at much lower level of political risk in some sense and organizational risk to start to build some let's crawl a little bit before we go try to tell the seismologists that we have some radical new way to find oil in the ground. So
I was going to say, when you first mentioned that it's these money-driven or money as a bottom line kinds of industries that are actually further ahead in their adoption, that doesn't sound to me like it's not an intellectual problem, it's more of a organizational problem, and maybe selling that to the management of the company.
Yeah, and I think in a sense, I mean, and I think this is where some of David's comments are relevant, is that there are areas where we need research done where it's not even clear there will ever be a payoff, right? Whether in improving human lives or whether in making anybody money, it may just be like, well, that was a cool science problem, and I was reading some work about some of the early efforts of the Human Genome Project, and pretty much none of the technologies that were developed during that phase are used anymore to actually sequence genes, for example. So I think there is definitely a bunch of areas we need to do research on, and think about is there ROI or not. But I think very practically thinking about the day-to-day of why should people consider using this? Why should companies consider using this? There has to be some case for either I can make an experience better, I can make some more money, I can reduce costs. You got to do something that actually shows some connection with what ultimately is the goal of the business. Otherwise, it is a research project, and it's very hard to justify research projects unless, again, they're promising some kind of benefit in the long run.
If I were an executive at a non-tech company who is looking into how I can better implement and solve problems in my organizations, what are some things that I should be thinking about?
Yeah, and one of the ways we try to approach this question is actually, I'll just digress for a moment and then come back to your question. I read something which was trying to articulate how a non-tech executive might perceive AI. And it was,
I'm excited to hear this.
Yeah, it basically started with imagine, so, we're all technologists and we've been around this stuff for a long time and whatnot. But it said, imagine somebody walked up to you and said, hey, I have this great thing called kerfuffle, and it's absolutely amazing, and it's going to be transformational. And you just stand there and say, like, well, am I the dumb one who doesn't know what kerfuffle is, and what am I supposed to be doing with it? And it might sound a little contrived, but I'll actually tell you, I was having drinks 2 weeks ago with someone who runs an $800 million business unit, healthcare-related business. And 40 minutes into our conversation, he said, can you pause for a second? What is the A in AI? And I said, well, artificial. He said, well, I know it's artificial, but like, why is it artificial? And I said, well, until now, like the only intelligence was in here, right? And so now we can do something else with it. So it just reminded me of the huge distance we have between our day-to-day and what we think about, and then coming back to like, what are the questions someone who's a non-tech executive, who's a line of business owner, some of the things they should be thinking about. So what we try to do, to help folks, sort of demystify this and really go back to this premise that it's a tool and you should think about business value, is try to use the language of the domain. So we have this idea of a solution brief, right? Yeah. And again, you've been in technology companies. You try to figure out, hey, what is particular workflows or particular, even sort of particular terms that may be unique to a domain. So I'll just give you an example. We obviously in e-commerce, we've been applying machine learning techniques for a while to figure out how to do recommendations better, how to optimize user journeys through a website, things like that. Healthcare, and particularly healthcare delivery systems, so large hospitals, I dealt with them a lot in the previous company we started. They're just waking up to the idea that, oh, maybe we can think of patients as consumers, and maybe we can try to improve their experience as a consumer. Well, it turns out if you translate a lot of what we've been thinking about in retail and e-commerce and bring that over and just talk about it in the language of, well, this is a patient-centric system. This is
it's really just human-centric.
Exactly, but again, people who live in that domain have a very particular set of vocabulary and problems. There's a certain way that problems are being framed to them, and so really helping them, sort of imagine, okay, oh, I get it. Like, when a patient comes to my website, we can take some of the data we have about them and personalize the experience. And just framing it in terms that they understand helps a lot. So I think in terms of non-tech executives, thinking about the right way to ask these questions, I think I'd almost say try to identify your top 3 or 5 business problems that you have where you say, like, look, this is what's going to move the needle. I know we have initiative around this more broadly. The CEO and the board are excited about this. The other really important point that Zia made, it's alignment across the organization. So for those of you, again, who've been around for a while, if you tried to do data warehousing in the late 90s, or you tried to do business intelligence in the early 2000s, or you tried to do analytics in the late 2000s, it's all sort of trying to make value out of data. The biggest challenge we had was that, person in organization A didn't want to share their data with person in organization B. It's great, you want to do machine learning on supply chain, but guess what? The person who owns the supply chain is not giving you their data. So what's your plan to address that? And so I think, thinking about some of the key strategic priorities and then having a conversation with a business-oriented technologist of like, hey, these are our 3 top priorities. Here's some of the things we're thinking about in terms of business, go-to-market, distribution channels. What can we do with a new set of tools today that we haven't considered, and try to look for some of those opportunities?
So that covers kind of the alignment across the organization and perhaps up to with the board and with the management. What about organization building, and either whether it's culture or talent or skills that you want to bring in to the company to make sure that you're equipped to actually create that sort of change?
Yeah, that's a great question. And I think probably relative to previous technologial paradigm shifts, transformations, whatever sort of big word you want to use, but moving things more to the web, thinking about mobile, some of those kinds of trends. It does feel like companies are, so just culturally, independent of technology, large non-tech companies are adopting technologies faster. It generally feels like when I go out and have conversations, I was talking to somebody yesterday about a mining company, they're actually already thinking about, they have someone who is doing some data science with their sensor data, and this is, I feel like we're a couple of years into at least some of the hype around this, and I was actually quite surprised that, wow, mining companies are thinking about these kinds of issues.
And it
right?
comes with consumerization too, right?
Exactly, yeah. And I think some of exactly the technologies we use day to day, where we start to expect that this stuff should be possible.
Yeah.
So I think that is definitely a part where it seems, again, just very small n in terms of our interactions, but it feels like people are getting this idea that every company has to be a tech company. You hear Domino's Pizza CEO say, I'm a tech company that happens to deliver pizza, or, sure. There's a bunch of other companies.
You're like, your pizza tastes like it.
Yeah. Actually, by the way, side note, compare Amazon stock's performance in the last 7 years to Domino's. Domino's is one of the few that's actually performed better than Amazon stock has. So there's something there. But anyways, in terms of organization building and so forth, I think companies need to think about a couple of things. One is, where do you want to build this organization and how do you want to build it? So, we sometimes hear, well, we want to build an enterprise data science platform, and we want to have an enterprise data science group. And I'm a little bit leery of platforms and these foundational groups and companies. I generally feel like creating pull with smaller problems and then slowly building on successes, which then gives you the political capital to start saying, look, this new way of thinking, of being more data-driven, et cetera, is actually resulting in commercial success. That tends to be the way I've seen people be successful. Otherwise, it tends to feel a lot more like, we brought in 1,000 consultants from Accenture, and we're going to do X, Y, and Z. And it's unclear how or in what time frame that might lead to success. So I think in terms of organization building, I think most companies should start thinking about where they want to have some of these capabilities housed, what type of other cultural changes they want to have in their organization. And then also, it takes a long time to change culture. I think pursuant to some of the earlier comments, we're humans. And my canonical example of changing culture is, think of the last time you installed a new iPhone app, and then were you using it 2 weeks later, right? We change our workflows very slowly, very infrequently. So I think that is a human problem that people should start on now. And I think that's an important part of getting value out of the tech, is that people are actually using it in their workflows to make decisions. I think in parallel with that, and this is some of where people have found working with folks like us is helpful, is they want to show success in sort of months or weeks, not years, and so that they can build some momentum. And so there may be projects where they say, okay, we have a pretty well-defined business criteria that we want to succeed against. We'd like to partner in some way and bring in specialized expertise in a particular area. So that could be another way you can try to get some success. Last thing on this I'll say is, notwithstanding all the talk about shortage of talent and so forth, I actually also think that there's almost a circular problem that it's very hard. If you've never interviewed a data scientist, or for that matter, a software engineer, it's actually very hard to know if the candidate you're talking to is a good data scientist or not good data scientist, or a good machine learning engineer or not a good machine learning engineer. So you end up with this problem of like, what is sort of your initial core group that's going to start building your team, and is it the right team for the types of business problems you want to point it to? So I think that's another area where we see organizations sometimes have a couple of missteps.
Yeah, it's almost like a general intelligence around it enough that you can identify
exactly
the right team.
what's the right way to build a team.
We have time for one question. Anyone would like to ask? Yes.
Have you looked at agriculture and farmers as a potential opportunity to take consumer AI and apply it? It's certainly plenty of big data.
Yeah. It's a great example where there's actually been a couple of successes already. I know there's a company. So short answer, we have not been involved with specifically with an agricultural related company, but I do know there's a company in Boston that took some work out of life sciences and some of the sequencing of, I think it was gut biome-related sequencing that they then applied to agricultural use cases. I think it recently became a unicorn company, and there's another one. I know there's a lot of activity in that area, for sure, but we have not done any work in that area ourselves.
Well, thank you so much, Vinay. And
Absolutely.
round
Thank
of
you, guys.
applause for all of our speakers today. Thank you so much.